We've already seen that when we graph a straight line, we can use that graph to really see how two variables are changing in relation to each other. But when we solve simultaneous equations, simultaneous means at the same time. So this means that we're often solving two or more equations at the same time. Now, if we can graph straight lines of each equation and look at how those straight lines behave on the Cartesian plane, then we can get a lot more information about how they might relate to each other. And this is really useful to solve problems. So before we look at how to actually solve simultaneous equations in the next couple of lessons, today we're looking at the graphs of them, just so we can understand what it is that they mean. So we're going to use an equation or perhaps use written information to make a table of values. Now you've done that before. Let's cut straight down to the bottom here. If I have the equation y equals x plus 1, then we've already learnt how to graph this straight line. We draw up a table of values for x and y, and we say if x is 0, what would y be? Well, you sub x is 0 in here. 0 plus 1 is 1. So if x is 0, y would be 1, according to this rule. What if x is 1? Sub it in. 1 plus 1 is 2. If x is 2, y is 3. If x is 3, y is 4. Y is always just 1 more than x, according to this rule. So we can graph this line here that I've drawn in green on the Cartesian plane by literally drawing up each of these as a Cartesian point. This is the point 0, 1, which we can put here. The point 1, 2, 1, 2. Remember, we look at the points along the x-axis first, then the y. The point 2, 3, the point 3, 4. And once you've got a bunch of dots, you can put your ruler on that and join it up as a line. And that makes that green line. That's the line y equals x plus 1. Similarly with this red line, y equals 2x minus 1, I've used this rule to generate a little table of values. If x is 0, what would y be? Well, plug it in. 2 zeros is 0. 0 minus 1 is minus 1. So when x is 0, y is minus 1. That gives me this point here. And similarly, I've made the rest of these points. When x is 1, y is 1. So that gives me this point 1, 1. I've got 2, 3, 3, 5. So this line goes up more sharply. And if you remember that it's graphed here in that form y equals mx plus b, where m is the gradient, that steepness makes sense because the gradient of this line is 2, which is a steeper angle, if you like, than this one, which only has a gradient of 1. So that's just bringing in some things that we've already learned. Okay, so we can use each table of values then, once we've made them, to graph a straight line. We've done that. Then we can consider the significance of any intersections. All right, well, let's identify where the intersection is of these two lines. It's right here at this point, and this is the point 2, 3. So we've labelled that as a key point. Remember that the x and y value of the intersection actually makes both of the equations true. So each of these lines is just an infinite number of points that join up to make a line. But this special point here, 2, 3, it satisfies both equations because it's on both lines. Let's just check. What this means is when x is 2, y is 3. Well, that makes this true because when x is 2, 2 plus 1, y would be 3. But it also makes this one true. If x is 2, 2 times 2 is 4, and 4 minus 1, y is 3. So see how it satisfies both of these equations. Now, how could we use equations like these and a graph like this to actually solve some practical problem? Well, let's make a story out of it. Let's imagine I've said to you, you've got two choices. You can either start with $1, and every day that goes past, I'm going to give you another dollar. See how rich you can get with that scheme. Or you can start by owing me $1. You'll start with minus $1, but every day that goes by, I'm going to give you $2. All right, the person that takes this scheme is following this red line here, and the person on the green scheme is following the green line. So after exactly 2 days, they would have the same amount of money, wouldn't they? Anything up to 2 days, the person who'd chosen this scheme would be poorer. But after 2 days, you can see that they're progressively going to become richer, and you'll see how much more money they'll have than the person who chose the green scheme. Now, that's a bit of an arbitrary example, perhaps even a little bit ridiculous, but in the business world, it's super common to use equations like this to work out where your break-even point will be how many items you're going to need to sell to make a profit or a loss, and how much profit or loss you might actually make. Now let's look at an example where we've got some written information and we need to draw up a table of values, graph some straight lines, and then have a look at that intersection point and use it to make some decisions. You work as a pizza delivery person and are trying to decide which pizza company to work for. Now, one company pays you $25 for a shift. Doesn't say how long that shift is, so just for the shift, no matter how long. But then you get $4 for each pizza delivery that you make. The other company, Company B, pays you $15 per shift. So straight away you can see that that's less just for turning up. But then you get slightly more for each pizza delivery that you make, $5 instead of $4. So this one looks like it would be the company to work for if you're not going to make very many deliveries, but surely at some point getting paid more per delivery, this one might work out better if there's a lot of deliveries to make, or if you're on a really long shift. So how many pizza deliveries are we going to need to make before Company B would be the better company to work for? Because we've got to try and think through how long those deliveries would take and whether your shift is going to be that long. All right, so drawing up a table of values for Company A. What is the variable here? What is the thing that we're not sure? We're not sure how many pizza deliveries we're going to make. That is the thing that could vary. We're definitely getting paid $25 just for turning up though. So if we make no deliveries at all when we're working with Company A, how much will we be paid for the shift? $25, right? So that's quite straightforward. Okay, now instead of saying 0, 1, 2, 3 deliveries, I've decided to look all the way up to say 15 deliveries because I'm thinking that if I'm there for a few hours, I'm going to make more than a couple. And by jumping bigger jumps here, I can get some bigger numbers to work with. Will hopefully show the relationship a little bit better. So now we're imagining, all right, what if we make 5 deliveries when we're working for Company A? Well, if we make 5 deliveries at $4 for each delivery, 4 lots of 5, that's 20. So we'll get $20 for the deliveries, plus the 25 just for turning up. 20 plus 25, that'll be $45. All right, what if we make 10 deliveries? 10 fours, 40, plus our $25, that's $65. Can you see a pattern here? It looks like it's going up by $20, doesn't it? And that makes sense because I'm making 5 more deliveries each time, and that's another $20. So I can see here that my next one, I'm going to make $85. All right, let's have a look at how we can graph that now. We've got pizza deliveries along here, and the amount of money that we're going to make for the shift. So if there's no deliveries, we're making $25, which is here. 5 deliveries goes with 45, so somewhere there. 10 deliveries, 65, looks like we're about there, and 15 deliveries, $85. Looks like it's somewhere like there. Now this should be a straight line, but of course I'm sort of reaching across and I don't have graph paper there. My ruler should have these, well they're not very straight at all, are they? 5, 45, that should be about there. We should be lining up with a straight line that looks something like this. Whoops, a bit wiggly at the end. All right, that's Company A. Company B, if we don't make any deliveries, we're just going to get our $15 for turning up. Let's graph the points as we go. So no deliveries, $15. So we're earning less at this company in that case. 5 deliveries, 5 fives are 25, plus 15, we're making $40. So we're still making less than Company A. 5 deliveries, $40, we're somewhere there. 10 deliveries, well, 5 tens is 50, plus 15, we're making $65. And you might notice that's exactly the same amount as Company A was making. So 10 deliveries, we're right on the same spot. And for 15 deliveries, 15 fives is 75. You can put these numbers in your calculator if you need to. And 75 plus 15, that's 90. So we're making a little bit more than Company A by the time we're up there. So then ruling up both of these lines, you can really clearly and easily see the crossover point now. And it happens when you're making 10 pizza deliveries. And at that point, you're earning $65 no matter which company you're working for. So this number here of 10 deliveries should be the key thing that we need to make our decision. Are there going to be 10 deliveries to be made when you generally clock in for a shift? Perhaps you could ask other people at work for this company and say, how many deliveries do you normally make per hour? And that might help you make your decision. You might be planning to work quite short shifts for this company. And if you're not working for very long, then the fact that you're being paid more for the shift might be more important than how much you're getting per pizza, because anything less than 10 deliveries, you're going to be better off working for company A. But if you're planning to do shifts that are quite long, then, and if you can reasonably expect to be making more than 10 deliveries every shift, clearly it's going to be better to be working for company B because you're going to make more money. Now, in this particular example, the crossover point was an exact point that we'd found in our table of values. So you might be thinking, hey, why did we need to graph this? I could tell from the table of values that this was the intersection point, and I could see quite clearly that I was going to make less money in this company until there was at least 10 deliveries made. Sure, but on another example where the crossover point isn't an exact number, you can guess the crossover point and still use a really good guess to make your decision. So for example here, if our crossover point had happened somewhere around about between 9 and 10, perhaps it was like 9.3 or something, well, you can't make 9.3 deliveries, but just by graphing whole numbers for each of your whole lines, if you can see that the changeover point is somewhere between, say, 9 and 10, you can still use that information to make your decision just as easily as you can when it's a whole number. And that means that actually graphing it is important so that you can spot that approximate intersection point.